What's up, guys? My name is Michael Lin. Welcome to my YouTube channel. Today we are going to do this problem, Codeforces round 666B power sequence. I could not actually solve this problem during the contest, so what I'm doing is I'm trying to upsolve this problem. I know it's a very strange time to be live streaming because for me it's 3 p.m. For you guys it's probably way in the morning, but I got to live stream because I got to switch my timing. So I probably will start live streaming way more earlier in the morning probably. So yeah, but in your guys' case in India, it will probably be at 6 p.m. nighttime or something. But yeah, I'm going to changing my live stream way earlier. But today we're going to solve this problem power sequence. And the first problem during this contest, I actually solved it very quickly. I solved it in like 9 minutes. So if you want to look at my standing, I did solve the first problem 9 minutes. This second one, I have like a problem of, so like if I can't solve a problem, like you get points deducted if you can't solve a problem, right? If you submit incorrect submission, at least for like education contests and regular contests. So like I'm pretty hesitant on whenever I submit something. I try to hesitate and not submit unless I can get 100% right. But yeah, I didn't really do that well. I did solve the first problem in 9 minutes, which was pretty good. But yeah, I didn't solve it that quickly. But I couldn't solve the second one. But yeah, it is what it is though. What it is. It's okay if no one's watching. It's just today is just it's a different time to live stream. Different time, different day. But yeah, sorry guys, I've had issues with like some school and stuff. School stuff is like affecting. My school just started for me, so yeah. Yeah, we are going to do this. Okay, so sequence C such that AI equals C to the I. We want to change our list of numbers so that it is be able to be something like this case. AI equals C to I for every I less than or equal to n minus 1. Right? That's what we need to do. We want to find the minimum cost to make it into a power sequence. So let's actually draw this out. I'm going to get my thing and I'm going to draw it out. Keep in mind, there is no editorial yet. I believe there's no editorial yet. I'll probably see if there is one, but let's see. I got to open up Google Sketch. SketchUp? Yeah, Sketchbook. Okay, so basically we want to change our sequence that they give us 1 3 2. So they give us the sequence 1 3 2, and we want to change it so that each of the indexes, let's say our index is I. This is I, right? Index is 0 1 2, right? We want to make all these sequences into these numbers into a power sequence. And a power sequence is when all the numbers in this array, let's call it A. Every array at an index of I is going to equal to a C to the I, right? For all I is between 0 and n minus 1. So n minus 1 is the length. N is the length. So that's what the problem is asking us to do, right? And C could be any number. So originally I'm thinking of just brute forcing it, just go through, and they want us to find the minimum cost. So for each cost, that means like you could increase the number by 1 or decrease the number by 1. So if I want to make this number, so like based in the source code, not source code, the input is 1 3 2. And let's say you want to convert it into 1 2 4, because that would be the most basic number to convert. So if I want to change this into, I shouldn't have done that. If I change this into 1, 2, and 4, this is going to take 2 operations, right? Because I have to add 2 by 2 to make this into 4. And this is going to take 1 operation because I have to subtract 1, right? So it's 1 operation. And this one's nothing, so it's 0. So in total, this minimum number of operations would take 1 plus 2, which will give us 3. So we are trying to find the minimum number of operations it takes to make this into a power sequence. So what you could do, you could brute force every single number, C, right? So I could start C starting from 0 to, I don't know, the largest number. So like for every C, and then I calculate the I, C of I for every number. So like if I start C from, let's say I start C from 0 to like, I don't know, 3. And for each of these, I check, I'm going to create like a sequence, like I'll do like 0 to the first power, 0 to the second power, 0 to the third power, right? And then do that thing. Actually, we shouldn't start C with 0 because 0 is not going to work regardless. But yeah, we would start C as like C of 1. C of 1, right? So if I brute forced, get the largest number, brute force, start C equal 1 to 3. I could do like C, calculate the new sequence. So it would be C to 1, C to 2, C to the second. C to the second, which is 1 to the second, which is going to give me all 1s. Calculate that, see if that works. Then I have to do like C to the second, C to the 1, C to the 2, C to 0, C to 0, my bad. This is 0, 0. 0, 1, 2, yeah. 0, 1, and then C to the second. Calculate this, 1, 2, 4, and then subtract this from the original for each of them. And then you would find that would be your number of operations. So I'm going to actually try that. I didn't actually code that in the beginning, so I'm actually going to try to do this. So I'm going to brute force C, start from 0 to like 2. Let's start with 2. 2 to the maximum number, right? And then, subtract the new values and then see if that gets us something. The only issue I have is this part, these, but yeah, it is brute force. So, actually, we should actually sort the numbers first from smallest to greatest. So then that would show the minimum operations would be the minimum. Yeah. But yeah, let me see the chat. Yes, I was going to sort it first. Yeah, I was going to sort it first. But yeah, thanks for telling me that. You got to sort it first. So yeah, okay. So we're going to input 3, 1, 3, 2. So first we're going to input number of values, which would be n, and then for each of them, create a vector of A's that has a size of n, and then we're gonna just read in this. Okay, so once we do that, so now you read all the numbers. Let's see, we're gonna sort it. And now we have to brute force our C. So to do that, let's start. We have to get the maximum number we're brute forcing. So, because I don't want to go to the 5th, to the 9th, right? That'll be too much. I don't want to just go through all 9th. So what I'm going to do is I'm going to get the maximum number, max num. Let's call it long min. We'll first make it the smallest number possible. And we're just going to get the max. Okay, so now once we have max num, so now we have this, and we sorted it. Technically, we could have just picked the last number. Whatever, it doesn't matter. Okay, we're gonna start our C value is gonna equal to 2, and we're gonna make it less than or equal to max num. So C is the base that we're doing, right? Now we have to create a new array, and we need to calculate each number for that array. Okay, so we're gonna do like vector new R. I don't know. Yeah, and then we'll call it n, size of n. And then we're going to go through new r. Go through all the values of new r. And then we are going to set each of them, so we have all the values of new r, to equal to c to the 0, right? So it would be power c to the j, right? So that's going to put c to the 0, 0 to the 1, c to the 2. That's what it's going to do. That's what we're doing here. So c to the 0 is your c to the 1, c to the 2, c to 3, all the way up to the number of numbers we have. So that's what we're going to do. I don't know if this would get TLE. Don't know if it will get TLE, but we'll try. Okay. Each of them, we will calculate c to the ith value, and then what we're going to do is we are going to subtract this number from a dot begin, a dot j. Okay, so we're going to do like, we need to like a minimum operations. So we need to have like minimum op is going to equal, let's make it the maximum number possible first. And then we are going to do, the minimum operations will be new r at j minus original a at j, right? The original value. And that's going to be the operations. So we're going to add these for each of them, okay? So it's going to be the absolute value, I think. I take it like absolute value. So we're going to call this each op is going to equal to 0, right? And then each operation for each of them, we're going to add. Let's call it absolute value of this. And then after that, we are for each operation that we do, for each sequence of C, we are going to just take the minimum. So we'll do min op is going to equal the minimum of each op, and then min op. Okay? After that, we're just going to see out min op. Okay. Yeah. Let's try this. Hold up. We don't need T. So we're actually going to get rid of this, and this, and this. Okay? I don't know why I did that. Okay, so now it's 1. Okay, it's 1. Okay, so now, yeah, that's right. Let's try 3. See, it's very slow now. What if we use binary search? We might be able to improve the efficiency by using binary search. So brute force by log base 2 of. So originally we're checking 2 is 2 to the max number, and then calculating it over and over again. What if we were to, I'm trying to think. Yeah, I think we could definitely use binary search. So let's see. How are you going to do binary search though? So let's say we have 2 to the 10 to the 6, right? So let's say our maximum number is 2. 10 to the 6 is the 1. So if it doesn't work, we're going to move the, if it's 2 greater, then, but then we have to compare the operations that we're doing each time. I don't know. Not binary search. Just keep a limit for C. Keep a limit for like C to the J. C to the J. What does that mean? So don't, when you get to, because I put C as the maximum. I'm not sure. I am not sure. How long have I been live streaming actually? I feel like, oh, I just started. Okay. So let's keep thinking. Keep a limit to the C to the J. Okay, so if another 10 minutes I can't solve it, I'm going to try to look for an editorial and try to understand their code. There might be, I don't know actually. Keep a limit to C to the J. But your J is not. I'm trying to think. Think. C to the J. Keep a limit of C to the J. Okay, we'll try to. I don't know. So like, what would your bounds be? Because like my C. Oh, okay. So if your C to the J is greater than. Okay, so if new R at J is greater than the maximum number of our array, if we just break, would that work? Just continue? I'm not sure. Because then if you're... I solved one problem in the contest. So in the contest, I solved one problem. I did it pretty fast, though. I did it in like 9 minutes, and that's pretty fast. That's a record for me. I can't do it less than like 5 or something. But yeah, the first problem I solved in 9 minutes. The second one, I didn't attempt. I looked at it. I tried to code it up, then I realized I could. This will probably get TLE, and I didn't submit it. So yeah, that's the reason why I didn't solve the second one. But yeah, let's see. This is just practice, pretty much. Yeah, I'm just upsolving. This. So if it's greater than T to the J, then we'll just break. Well, it still gives you a TLE though. Let's see. Let's see. Okay. C to the J would probably end. Oh wait. Okay. Let's create like a limit. So while limit is equal to false. Once this limit is true, so we're gonna set limit to true, break. This is gonna break out of loop, okay? I don't know if this would work. Huh, okay, I got something. 968376. No, that's not the minimum though. 968376. Answer's not right. Let's see. 10 to the 14. Where did you get 10 to the 14 from, though? Nah, I don't think that would work. 10 to the 6? 10 to the 9, probably. Maybe it's 10 to the 9. No, it's still the same. 12? Did you just guess? How do you know the limit? Nah, that doesn't work. Yeah, I got no ideas. No ideas. Let's see. Maybe we should just try to search the editorial. I'm gonna try to find the editorial actually. Let's try to read the editorial, understand that. And then we could probably be able to solve this problem. Let's see, editorial. Unofficial editorial. Okay. So let's see. Sort the array, enumerate it. We constrain C by n minus 1 is less than or equal to the sum of 2 times A of n, I. Huh. Sum of 2 times AI. Why? Where did they get 2 times A of I? Let's try that. So here, instead of max, let's do like a comment out max. I'll do like sum. Okay. Let's do sum. Yeah, we're gonna do sum. Okay, so we're gonna do like sum, and we do sum plus equal A of I, and then we're gonna do constrain it less than 2 times sum. I don't know if this would completely work. Enumerate C, constrain the range of C by 2 times I, and then if it's greater than 2 to the n minus 1 has to be less than or equal to 2 times I. Okay, so this would be 2 times sum. Okay. Let's see if this works. Well, we're getting closer, but we're not actually following the right example. The numbers are not right, though. So we are getting closer. 9225539. If you constrain the number of C, two two five three nine. 2253. That's not right. That's not right. Okay. Let's see. What are they doing? Okay. Sort it. Enumerate C. We must constrain the range of C by C to the n minus 1. Otherwise, we can simply change all AI to 1. That would cost less. Change all AI to 1. You could try that. So for each of them, let's do, so we had minimum operations here. So let's put this on the top. And then here we're going to do is we're going to subtract each of them by 1 to the I, which is just going to give you 1. So yeah. So now what we're going to do is we're going to take a of I minus 1. And then, yeah. Okay, so we're going to do like minimum operations is going to, actually we start at 0. Then do minimum operations is going to equal plus equals to a of I minus 1. And then we do all the thing over here. Min op is going to equal to min op eco. Okay, let's see if this works. Two two five three nine. Okay, that's still not right, but we are close. We're getting close. Getting close. Maybe we should read the Python code. What does he do? Okay. S is 2. Okay, it just goes 2 to the n minus 1. Okay. S is a sum. Okay. So that's what we did. We start b of I is equal to 1. We append the last number multiplied by j. So that's 2 to the first, 2 to the second, 2 to the third. Okay. Then they subtract for each range, sum them up, and make the cost. Increase j by 1. Didn't we? We're doing the same thing, right? Oh, okay. I guess we're not going to use this. We could just comment this out. Do 2 to the c to the I, j plus equal to abs of b minus 1. It should be work. Yada, yada, yada. I guess we're going to comment this out. Do they start with 1 or 2? They start their C with 1 or 2. 1 to the 1, 2 to the 2. Let's see. 1 times 2 to the 2 to the 2, 2, 2. 1, 2, 4. 2 to the 0. This should work now, I think. Well, it doesn't break. It takes a long time. Let's see. 2 times C++, enumerate, create your array, j plus equals each op minus. I don't know why mine's taking a while. Start with 1. Okay. We could start with 1. I can't make it. Oh. Let's keep this back then. Let's keep this back. It was still the same number though. Try to think. Start with 1. J plus equal to 1 for every I range 1 to 0. Cost total cost. Min cost total. Cost is S minus N. Why is it cost S minus N in the beginning? Oh. Total sum minus So if you make it all ones, it would be total sum minus n, if they're n ones. So it would be total sum minus 1 plus total sum minus 2. Okay. Yeah, that would make sense. Okay. So s minus n is the beginning. But that's what we did. I don't know. I don't know why I'm not getting the right answer. Let's keep thinking. New array minus j minus a plus equals power each op multiply. Make the upper bound between 1e to the n. At worst case, we can make all elements 1, i.e. 1, 1, 1, 1. Thus, the upper bound would be k to the n, which is equal to n times 1e to the n, which 1 times e to the n. That is what we were doing before. Trying to figure it out is very hard. Let's see. Start with c equal 1. Upper bound is k to the n equal to n times 1e to the n. 1 times n times what? Ha. 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 Does this work? Did it work? No, that's not right. Hold up. What if I change min op to, let's put it down in the bottom, sum minus n, okay? That's basically what we were doing before, but now it's just more clean. N times 1e to the n. N is the 2 times to the sum. False. Upper bound of the power. K to the n. K to the 1. C to the n. Is this? I don't understand. Let's keep looking. Keep looking. Sometimes 2. While the power of j of 2 to the n minus 1 is less than or equal to to the sum times 2. Power of j2, n minus 1, less than or equal. Oh, okay, this is okay, multiply by 2. Multiply by 2 that many times, multiply the cost. That's what I was doing, though. But they're starting it by so their n value is 2. No, their c value is 2, right? And then multiplying into 2. Then they do append, they sum them up. Total cost j plus 1, n minus 1, 2 to the n minus 1. What am I doing wrong? Total minimum cost. Trying to figure out. Still trying. We'll figure this out. Don't worry. So they're starting from 2. They don't even have an bounds. Hold up. Let's just try rewriting their code, okay? Okay, I'm going to comment this out. So we did the same thing of sorting. already did that. So we have the min cost. They're starting their C from 2. So let's do like while power C is equal to 2. 2 to the n minus 1 is less than or equal to sum times 2. Okay, so we're gonna do, yeah, okay. And then now we're gonna check, do C++. Okay, we're gonna create an array. The first one is gonna have value 1. B, let's call it B. It's gonna equal to 1. And then what do they say? For every k from 1 to n minus 1, k plus plus. Append multiply by, so yeah, 0 to k minus 1. Actually, it should be 1 to k. 1 to n minus 1. Yeah. So originally 0 to n. Now it's 1 to n. 1 to... Okay, now it's 1 to n. Okay, that makes more sense. We're going to do p dot pushback. B dot, what was it? End times by C. Why can't I do this? Back. I think it's back. Yeah, back. Last value times C. Then we're going to subtract some operation is going to equal to 0. For every I equals 0, I is less than n, I plus plus. Operation plus equal to b of I minus a of I, ABS, right? Then we do min cost, min op is going to equal to minimum of operations and min op. Okay? Yeah, and then after this, we're going to see out min op. Let's see if this works. Okay. Oh, it works. Okay. Okay. Why did they use 2 to the n minus 1? N minus 1 is the last. So while C is less than or equal to the sum. Okay. That's a weird thing. Okay. Let's submit it and then on to the next problem. I think it was power sequence. Yay! That's what I'm talking about. I should have actually showed like failures of submission, because now I think code drills will think that I did this on the first try, which is not true. But whatever. Okay, so Chethan, sorry dude, I didn't read any of your messages. You want E to the B? Okay, yeah, I didn't know, I didn't read it. My fault. But yeah, I did understand the pseudocode though. I do understand the reasoning, why they did it. But yeah, let's go to the next problem because I'm gonna try to keep us tempting. Did I say? My bad. Let's see. How much live stream did I have? Oh, okay. So this one I said this live stream is only Upsolving 666 Div2B power sequence. So now that I upsolved it, I'm actually going to exit this live stream and create a new live stream for another one. So just in case if people go to this problem and then by accident they don't, you know, they see a different solution, right? But yeah, for now, I'm done with this live stream. This is going to be a quick live stream. Feels bad, man. Yeah, my bad, dude. So I just feels bad. I didn't read it. I should have read it. Okay. I should be like one of those people who have those dings whenever someone comments. You know what I mean? But yeah, that's it. That's it for today. Tomorrow I'll try another live stream of solving the C problem. But yeah, rate, comment, subscribe. I hope you guys enjoy this video. It feels bad, man. Yeah. That today was the end of the live stream. Tomorrow I might live stream earlier, so at probably 9 a.m. Eastern, which is gonna be 6 p.m. of India time. But yeah, hope you guys enjoyed this video. Rate, comment, subscribe. I'll check you guys later. Peace.